So we have a lot of marine biological threats nowadays. We have toxic bloom, viruses, invasive species, which one example, for example, we went to 800 million USD losses in Chile in just 1 week, which led to 23 million of fish deaths, and also a civilian unrest, which lasted for months because the aquaculture industry had 20,000 redundancy. But an early warning system can actually eliminate or mitigate the impact of these threats. So our solution is called CyDX, which means CRISPR-Cas-based biomonitoring of emerging substantial marine biological threats. And this is in 3 steps happening. First, we use a machine learning approach. This machine learning approach basically allows us to design almost automatically from genomic data the guide RNAs. And the guide RNAs basically guide our programmable protein, which is Cas13, to an environmental DNA, which usually the biological threats are going to be in the environment. So they are going to shred DNA, and we are going to have DNA in the water, so we can actually detect it. And when we detect it, we are going to have a detectable signal with fluorescence, which basically is a peak. So we know this presence, so we know that we have to do something there. And then, when we have this platform set, which is already set, we can actually use this. Oh, this is not. This, which are chips, graphene chips. So basically, these graphene chips can detect a small change in voltage when the CRISPR-Cas detection are happening. So we are going to have an electric peak in the system. And we have a peak, we are going to have a detection. And usually, electric systems are more easier to integrate into electrical system, which make them faster and better. So our advantage for now are high specificity and high sensitivity. We have results in less than 50 minutes. We have a robust detection even in presence of inhibitors, and also our reaction are only 4 to 8 USD per reaction, which is really cost effective. And I want to stop in the high specificity and sensitivity because basically this technique is able to detect any of us in this room. A high sensitivity is basically 1 in millions or trillions of molecules. So it's high sensitive, so we can detect very early on when we have an infection or a bloom or an invasive species here in New Zealand or in the world, so we will be able to reduce the impact of this in social, economic, and more importantly, in our ecosystems. Thank you.